And compound inequalities typically don't include the word and at all. Usually it's written so that the variable we are trying to solve for, in this case y, is centered in between two constants or two other expressions. There are multiple ways that we can solve and compound inequalities, and I'm going to show you two of those ways. First, you have the option to split any and compound inequality into its two separate simple inequalities. Both of these inequalities can be solved independent of one another using all of the steps that we are used to seeing. In this case, we end up with y is greater than 5. The other simple inequality will get solved the same way. We'll divide, and we're left with y is less than or equal to 10. Because this is an and compound inequality, we need both of these things to happen together. If I'm looking at a number line, I've got 5 on the number line, and I've got 10 on the number line. If I'm greater than 5, I'm shading all of this way. If I'm less than or equal to 10, I'm filling in this circle, and I'm shading all of that way. The solution to the compound inequality is the region where we see the intersection, the region where we have the double shading. So the solution would be that I need to be greater than 5, but less than or equal to 10. Oh, excuse me. It should be a y. The other way that we can solve these is by using a recognition from over here. Notice how this step right here and the step that got us down to the end were the same. There's nothing stopping us from solving this inequality all at once and adding 7 to every part of the inequality. That should still maintain the fact that they're all not the same. Or in the case of this equal to over here, it could be the same. 15 less than 3y less than or equal to 30. And then we'll finish by dividing by 3, 5 less than y less than 10. And we end up with the same, less than or equal to 10. And we end up with the same solution space. When we write it like this, we can also jump right to the solution space shading and say that I know it has to be between 5 and 10. A little less work over here, a little less graphing, a little less shading, might be a little bit quicker a strategy to use. Looking at another and example, it's possible that the variable that you're attempting to solve for could be in one or multiple places in the inequality. In this case, we see the a in 3 different places. We've got an a here, we've got an a here, and we've got an a here. Because we're trying to solve, it probably wouldn't be a bad idea to begin by distributing. And I end up with an inequality that looks like this. If you remember our work with variables on both sides of an equation or both sides of a simple inequality, the work we're going to do here is very simple. We're going to choose the middle as the location for the variable. If we're going to want to do graphs similar to what we did in the last example, we're going to want to make sure that our variable is in the middle. The variable has to have a boundary. That's how we're going to graph it. If that's the case, then I'm going to take a away from the left and a away from the right, and isn't that convenient? It leaves us with negative 16 on the left, less than or equal to a minus 8, which is less than 2. I add 8 to all 3 sections, and I get negative 8 is less than or equal to a, which is less than 10. And my solution space is going to be in between the numbers negative 8 and positive 10, inclusive of the negative 8, exclusive of the 10. Just because the variable appeared 3 different times at the beginning does not mean that I don't have the option to eliminate it from the outsides, center it into the middle of the inequality, the compound inequality, and solve it just like I did the others.